Okay, howdy. Sorry, I am going to be gone today, so I have a cross-country meet. And so I recorded the video just so the notes go by a little bit more easily. And so you guys know what you're doing for today. We'll still be looking at your quizzes. You will have a homework assignment. And hopefully you submitted your labs. Hence why I have this slideshow up right here. So please, your toy car lab, your buggy lab, please make sure you turned it in. It was due this morning, and I will be grading those. Remember, there will not be corrections this time around. So make sure that you turn it in once it's complete, once you're 100% about it. Still ask questions. I can help you as long as it's not turned in. Okay, once it's submitted, then the grade, once it's going to be graded, and what grade it gets is going to be what it is. Okay, so with that being said, I apologize for any noises out in the hallway. I'm recording this one day early, so there's some lab stuff going on outside. But I would like to help you guys with the lesson for today. So with that being said, please take out two things. You're going to be taking out your Chromebook, open it to the lesson plan page for today, September 16th. Once you get there, close your Chromebook. We won't be needing your Chromebook until the end of the hour. So once you do that, you can go ahead and put your Chromebook away, go charge it, whatever. The second thing you're going to need is your notebook. We're going to be taking notes. So this is a great time to pause the video, pause it, and have everyone collect those things, start the video back up once everyone has them. Great. Okay, so hopefully you have your notebooks open. We're going to be starting with notes for today for Unit 2, okay? This has to do with our lab that we started yesterday, which was about constant velocity, okay? So we're going to be starting today. Swipe, okay? We're going to be talking about position versus time graph. So if you could please title this portion of your notes, Position versus Time, okay? Big words, top of your notebook, position versus time. And then I would also appreciate if you guys could, on the right side, okay, right side of your notebook, underneath the title, position versus time, if you guys could please put a graph, okay? Just make a graph just like this one here. It doesn't have to be very specific, okay? You don't need to use the units or the number values here because I have 1, 2, 3 meters, and then I have 1, 2, 3, 4, 5, 6, 7, 8 seconds on the bottom. You don't necessarily need that labeled for this graph, okay? But what I will need you to have is a graph, so an L shape, and you need a line going up on your graph, okay? So please get that down, and then I'll move on. Okay, so position versus time. This is going to get a little wacky, okay? So I've always told you guys that your independent variable is always going to go on the x-axis, the bottom, okay? And time is always going to be the independent variable. Everything is affected by time. Time is independent, so time always goes down here, and that's your x-axis. Your y-axis on the side, okay, that's your dependent variable, and so we have meters. So for example, like with the buggy lab, when the car was driving, when you turn the little buggy on and it's driving, over time, it would travel a further distance, okay? So, easy enough. Now, this graph is going to kind of mess up your concept of your x and y a little bit, and that's why I'm highlighting this now, okay? So, for a position versus time graph, it's called a XVT graph, okay? Now, swipe. Your y-axis is a position, okay? So a position versus time graph. So for example, meters is a position. Well, we're going to technically change how we're calling our graphs. So on your y-axis right here, it is measuring meters, but what I would like you guys to draw is right here on your y-axis, this is going to be x. This is called x. X references your position, okay? Not to get nerdy here, but if you were to reference like Minecraft in this scenario, like you have your x, y, z coordinates, x is one of your position coordinates. So we're measuring a distance, and we're going to call on a position versus time graph. X is going to be your y-axis. I know that's confusing, but if you ever see an x on the side, just know that we're talking about how far something is traveling over time and which direction it's going. Okay, so please put an x right here on your position versus time graph, your XVT graph. Okay, now based on that title, XVT, position versus time, x is on the side. I'm assuming you guys know what to put on the bottom there. Okay, next we're going to put t for time on the bottom. Okay, so x on the side, t on the bottom. I'm going to erase this. I'm going to keep going with the slide. Beautiful. So, slide. So x-axis is going to be time, it's abbreviated as t. Beautiful. Now, the sign of the slope indicates the direction, okay, whether you're going forwards or backwards, if you're going away from the starting line or if you're going toward the starting line, okay? So I like to think that anytime we're measuring distance, okay, 0 means starting line, and then the higher you go, the further away you get from the starting line. So I like to think that this whole line right here, this whole bottom x-axis, okay, when m or meters equals 0, this is your starting line, okay? Now, you have to ask yourself, with that blue line that's on the board, I hope you can tell this is blue, but this line right here, okay, does that have a positive slope or does it have a negative slope? And hopefully you guys are good with your algebra, maybe algebra 2, okay? You should know that that slope is going up, so it has a positive slope, okay? So since this has a positive slope, I'm going to put in parentheses positive, and please write this down, this point specifically, make sure you write this down. The sign of the slope indicates the direction. So if you have a positive slope, that means you're moving forward. You're moving away from the starting line. Okay, you're getting further, getting toward your destination or your finish line. Okay, so anytime the slope is going up, you're going forward. Now, if it's going down instead, so let me erase this. Let's say you guys have a different line and it's starting to go down. This one has a negative slope, it's going down, and this means you're heading backwards. Okay, you're heading back to your starting line. Remember, this is all in reference to your starting line, which is 0 meters. And if you're heading towards 0 meters, you're heading to your starting position. Okay, you're starting. So make sure to get that down. If it's a positive slope, you're going forward. Okay, if it's a negative slope, you're going backward. Slide. There we go. Now, the value of your slope, your m value, we've been looking at this multiple times with Vernier graphical analysis, but the value of your slope indicates your speed, okay? So the higher the m value, instead of having an m value of like 0.5, if you have an m value that's 1, well, 1 implies that you're faster. The higher the number for m, the faster you're going. So that translates to a graph that the steeper / greater the slope, that means the faster the object. So as your slope gets more vertical, as you get more straight up, it's going to be faster, okay? And as your slope gets more horizontal, like so, it gets slower, okay? So as it gets more horizontal, this means slow. This here means slower. And as you get more vertical, this means faster, okay? So steeper the slope, the faster you're going. I think that's a pretty easy concept to think about. Next, sorry. So I used to use my computer for the slideshow. Go, slide, not sliding. Oh, I see why. Because I'm still in drawing mode. Discard. Beautiful. I missed a dot. Okay. Last but not least, the y-intercept indicates the starting position. Okay. So if someone doesn't start at 0, someone doesn't start the starting line down here. So that again, this is your starting line. This is your starting at 0. If you start at something like 1, for example, this means you get a 1 meter head start. Okay, you start in front of everybody. So the y-intercept says how much of a boost you get, how much further ahead you get to be compared to everyone else. But it can also go in the negative direction too. You can go even further behind the starting line. That's not abnormal either to see. Okay, so your y-intercept indicates whether you're starting further beyond the starting line or if you're starting further behind the starting line. Okay. So position versus time. We're going to be practicing this a little bit. So with that being said, I want you guys, you can put your pencil in your notebook. Okay. Close your notebook for right now. I need one person from each group to go back, grab a whiteboard from either of the two stacks, grab a marker, and grab a rag, okay, and pause the video. Once everyone has that, then restart the video. Okay, so I'm going to see if you guys on your whiteboards, if you guys could figure out the answers to these questions right here, or statements. So we have a red line that's going up, so red going up, blue going slightly down. I want you guys to describe the motion of these objects. Which line is going forward? Which one's going backwards? Okay. I also want you to describe how fast are they traveling and in which direction? Okay, so also talk about their speed. Last but not least, what position did they start from and how do you know? Okay, so pause the video, see if you guys can answer some of these questions. Once it seems like most groups have something down, please start the video again. Okay, well, hopefully you guys have your answers. Let's see what we got. So I believe we're going to start with the red line. The red line. Beautiful. So the red line, since it has a positive slope, it's moving in the positive direction. That means it's moving forward. Okay, so moving forward, positive slope. Now, how fast is it moving? It's moving pretty darn quick. Okay, since it's a pretty steep slope, it's getting pretty close to being vertical. Okay, it's more up and down than it is left and right. Since it's more vertical, it's moving pretty quick. Okay. Now, its starting position, it started at 0. It started at the starting line, okay? It started at the starting line, and it moved away from the starting line forward very quickly, okay? So that's the red. Now, what is the blue like? Now, the blue is going to be almost the opposite in every single nature, okay? So first, does it have a positive slope or a negative slope? And you should see that blue is moving down. So if it's moving down and one day it's going to hit 0, it's going to hit the x-axis, time, that means we are moving backward. Okay, we're moving toward the starting line. Then the question is it moving fast or slow? Well, if you look, blue, it's not horizontal, but it's getting pretty darn close. So I like to use the x position axis and the t time axis, and whichever one it's closer to, I use as reference for fast or slow. So I wouldn't say it's very up and down. Okay, the blue line's not very up and down, so it's not moving very fast. I would say it moves more left and right, like the time axis in the bottom. Okay, and since it's more horizontal, that means it's moving pretty slow. Okay, it's pretty flat. Now, did it start at the starting line? No, it did not. It started about halfway up, okay? And so that means it started ahead of 0. It got a head start, okay? So let's say the very top of this graph is the finish line, and this is the end of the race. This person started almost at the halfway point in the race. And instead of going toward the starting line, they move slowly to the, or sorry, instead of moving to the finish line, instead of blue moving to the finish line, they move very slowly toward the starting line, okay? So this is one general concept I'm expecting you guys to know, is describing whether it's moving forwards or backwards, which direction is it moving, how fast is it moving, and where did it start, okay? Did it start halfway beyond the starting line? Did it start at the starting line, or is it more close to the finish line, okay? So these are things I'm expecting you guys to know. So please erase your boards. Erase your boards, erase your boards, erase your boards. Hopefully they're erasing their boards right now, okay? We're going to go over some more practice problems. Beautiful. Now, I want you guys to answer this question next. This one's pretty easy. I like to think it's easy. So we have two lines here. We have A, that's moving up pretty fast, and we have B that's moving up pretty fast, but not as fast as A. I want you guys to compare the motion of A and B and what happens at T. When T time equals 4. Okay, so when T time equals 4 seconds, what is happening at that specific position? Write down your explanation on your board, okay, a sentence for each, and then pause the video. And then start the video once everyone seems to have an answer. Perfect. Okay, so compare the motion of A and B. So A is moving forward, and it's moving forward pretty darn fast, okay? And A started at the starting line, okay? Started at the starting line, started at 0, moved very quickly toward the finish line, okay, as it's moving up. Now B is moving forward. It's not moving forward as fast as A, but the nice thing about B is they got a little bit of a boost. They started ahead of the starting line of our 0 position. They got to move 20 centimeters more forward, okay? So now the question is, what is happening at T equals 4, where the lines intersect right here, okay? What's happening right there? Well, down here says we have the same T value, which is 4 seconds. So it means at 4 seconds, they are both roughly at the same location. So A and B are at the same location. So that means they traveled to the same spot at the same time. So realistically, if I were to describe this almost as a race, ignore the centimeters part. Let's say this is like a race, okay? And A started at the starting line, B got a head start. Now, this entire time, A is catching up to B, and then right here, A and B are right next to each other. They're at the same position at the same time, and then A runs past B, okay? So they're at the same position right here. A is catching up to B, and then after this point, A surpasses B and B starts falling behind, okay? So, position versus time graph. I would recommend you guys draw a graph, very basic one, just an L shape in your notebook, okay? So take out your notebooks, draw an L shape for the graph, draw an A line, a B line, and please describe what happens right when they cross. What happens? A and B are at the same location. So please, everyone write that down, pause the video, and then start it again once you guys have written that down. Beautiful. Okay, so hopefully you wrote that down. I think this is a fabulous example. Next, this one is the longer part of the notes, and this is going to be your guys' practice problems. This will help you for the homework for tonight. So this is the position time equation. So you can go ahead and write this in your notes. It's up to you if you want to or not. Position time equation, and make sure to write down this equation right here. Okay, this equation is not quite like the ones that you've written before. So the position time equation is x, so position, so x is your position, equals v. V in this scenario, you can go ahead and write down. You'll write down in a second, never mind. So x equals v times t plus x of 0. Okay, and we'll go over each of these. These are written right here. So write down the equation. And now also write down what each of the letters stand for. Okay, so x stands for your position. So it just stands for where you're at. Next, we have v is velocity. Velocity is technically your slope. Okay, so remember, if you're measuring the distance, x, over time in seconds, distance over time is known as your speed. Okay, so this is your speed. Now, I'm going to go over what speed and velocity are in a second. But again, make sure to write down. V is velocity, and that's going to be your slope. Okay, so this v is going to be your slope. Now, the last thing I want you to write on the v is velocity part, a lot of people get confused. We went over this on Friday with you guys, but velocity is the same thing as speed. It is the same exact thing, except it includes, there we go, includes direction. So be very careful. If I'm saying speed, I'm just asking how fast something is going. If I'm asking for velocity, that means I'm asking for how fast something is going and which direction is it going in. Okay. So for example, if I'm saying I'm going and driving to my family members, okay, that live in Richmond, and so I'm traveling on 94, I would say, oh yeah, my speed when I'm driving is 70 miles per hour. Okay, so that's my speed. But if I were to include my velocity, if you ask for my velocity instead, I would say, oh yeah, I'm heading 70 miles per hour due west on 94. Then when you guys hear that, you should think velocity because that I also included a direction there. Okay. T stands for time. That's pretty easy. Hopefully you got that down. Last but not least, x of 0. 0 just means when x equals 0, what is your starting location on your y-axis? Okay, so x is the starting point. It's the starting position. It is your y-intercept. Okay, so that's why it's at the very end. This is the same as y equals mx plus b. It's the same exact formula. We're just replacing them with other letters that represent our position versus time graph. Okay, since direction, okay, or not direction, our distance in meters, m is our y-axis, but now on a position versus time graph, instead of saying y, we say x. X stands for position. We replace y over here with x, and we do that with all the other letters too. Okay. Oh, now the question is, do I want to be mean or do I want to be nice? I think you guys do need some practice with some math based on your guys' quizzes, which we will be going over. So I'm going to erase this. Now, you guys want to use the equation above. If the cart runs for 45 seconds, so imagine this graph shows a cart, okay? And so a cart is traveling meters per second. If the cart runs for 45 seconds, what position will it be? okay? Or what position will it be in? So in order to answer this question, you guys need to use this equation up here. You have to use that equation. You have to figure out what is your starting point, okay? What's your velocity, okay? So you need to figure out these things. I gave you 45 seconds, so the 45 seconds is going to go in for t. What you're trying to find is x right here. Now, the velocity, that's going to be a little tricky for you guys watching this video, so I'm going to give you a little hint on this, okay? I'm going to give you a little assistance. Just so you know, you should be able to answer this and use this for your velocity. This slope, okay, velocity is your slope. The slope of this line is when you go over 4 seconds on the graph, you go up 1 meter. Okay, so this is 1 meter for every 4 seconds. Now, I want you guys to solve for this on your whiteboards. Solve for this, use this equation, see if you can get my answer, okay? With that being said, please pause the video now. Okay, now, hopefully you guys have an answer. I already did this problem, so I'm going to go through on how I solve for it. It's not too shabby as long as you follow the direction and you know Algebra 1 level math, okay? So, I'm going to erase the rest of this. I don't need this. Let's do this. Discard. Beautiful. Now, what we're solving for is x, okay? Now, I said the slope, as you go over 4 seconds, you go up 1 meter. So, my slope is 1 meter for every 4 seconds. Okay. I said I'm going to plug in 45 seconds. 45 seconds. And my starting position, if you look here, starting position is your y-intercept. My y-intercept was 1 meter. Okay. So I'm going to add 1 meter. Beautiful. So if you take 1 over 4, which is just 0.25, and you multiply it by 45 seconds, you should get 11.25 meters. And that's going to be plus 1 meter will be my x value. Okay. Now, if you add these together, the final position you'll be at in 45 seconds is 12.25 meters. And that's what you should have got for an answer. Okay. So I think this is a good practice problem. I'm probably going to test you guys when we get closer to the quiz on doing problem number 2 and number 3. I'm going to save those ones for later. But it is good to know that you have to be not super strong, but you have to be competent in algebra, okay, for this unit. So with that being said, this is one of the main equations we're going to use. This is an example problem that you may have on your homework tonight, okay? So not too shabby yet. I like to think this is not too bad as long as we get that practice in, okay? Discard. Now, on your whiteboards, we have this graph. I like to think this one's a little easier. I want you guys on your whiteboards, okay? Number 1, 2, 3, 4. Number 1's fastest, number 4 is slowest. I want you guys to rank letters A, B, C, and D from fastest to slowest, okay? Pause the video. Hopefully you get an answer. Okay, let's check those answers. So, I'm asking for speed. I'm not asking for velocity. So I just want to know how fast is the thing going. Okay. So with that being said, the first fastest line, my number one for the fastest is going to be A. Okay. A is the fastest. So you don't have to be traveling in a positive direction to be considered fast. If you look, the blue line for A is moving down, okay, pretty quickly. I would look at all these lines. If I look at A, B, C, and D, I would say C is pretty horizontal, if not perfectly horizontal. D is pretty horizontal. B isn't super horizontal, but I would say it's more horizontal than it is vertical, okay? But I would say A is the closest to being like a perfect mix, okay? I would say it's equal parts horizontal and vertical, okay? So I would say A is the steepest line. I would say that's, if I had to walk up this line, this would be the one that would feel like it's taking the most effort. Now, what's the second fastest? Second fastest could be B, because I would say this is the second steepest, okay? Just again, figuring out which one's the fastest, just look at the line. Is it more vertical, horizontal? If I had to walk any of these paths, which one would take the most effort? B, I would say, takes the second most effort. It looks pretty steep. Okay. After that, I would say number 3 is D. D is pretty horizontal. I would say that's pretty flat. I would say that's like a small uphill. I don't even know if you would feel that on your legs if you had to walk this slope. It's not that bad. Okay. So the slope is pretty low. It's pretty horizontal, so it's not that fast. And that leaves number 4 with C. C is perfectly horizontal. Okay. If it's perfectly horizontal, that means its position over time isn't changing. And if I stand still, okay, and time passes like it is now, that means I have no speed. This person has no speed, okay? For example, A has speed, and they're going backwards from the starting line. B has speed, and they're moving away from the starting line. C is just someone that's standing still, and they're not moving. They're staying in the same spot over the entire time, no speed, okay? So they're the slowest. These are not moving. Alrighty, that's pretty good. And now the scariest one, in my opinion, writing meaningful equations, okay? Now, you can't forget those meaningful equations. You have to include your units, okay? And since I know you guys are still struggling with this just a smidge, I'm going to help you write a meaningful equation for one of these. And I don't think you need to go that extreme for it. So, for example, for a meaningful equation for this graph, I'm going to start with A. I'm going to do A's meaningful equation. So, again, the equation is x equals bt plus x of 0. So I have to ask myself, what is x? Okay, x is going to be my vertical axis on the side here, so that's position. Okay, so I'm going to say position. So position, that's my x value. If I want, I can skip velocity for now. I can put time, because t stands for time, and that's the bottom axis. So this one is time. You can either put time or you could put seconds. Both are relatively synonymous. Okay, either works. Now velocity. Your velocity is your speed. And if you're measuring something's speed, what you're really measuring is distance over time, or its position over time. Okay, that's very definitive. So the question is, after I write down position over time, you guys need to ask yourself, can I figure out what the slope is? Can I figure out what number is supposed to go here? And for A, at the very least, I can. I can find out what A is pretty easily. Because if I look, we start at 10 meters, and over 10 seconds, we go all the way down and we pretty much hit 0. So if I'm going from 10 all the way down, okay, in 10 seconds, I lose 10 meters. That means every time a second passes, 1 second passes, I lose 1 meter. So that means my slope is negative 1 meter per second. So I'm going to put a negative 1 here. Negative 1. Okay. So negative 1 position per time, or meters per second. Last but not least, we need that starting position. What was the starting position? The starting position on the graph plus x0 is going to be where x equals 0, aka my position. No time has passed. No time has passed. Where did I start? I started at 10 meters. Okay, don't forget your units on the very end here. Again, on the quizzes, I saw a lot of people saying plus 10, okay, or plus this, and not putting a unit at the end. So make sure you write that down too. Now, I'm going to look around, and I'm going to call on people. Hopefully these people are here. If they're not, that's a little embarrassing. But I'm going to call on groups, and your group is going to work on a specific line. I did A, so no one can do A, okay? I hope that makes sense. So, Delaney, your group, you guys are going to try to make a meaningful equation like this one. It's going to look very similar to this one, okay? But you have to watch that potential negative. You guys are going to be doing line B, okay? Jake, your guys' group, I'm going to have you guys do C. I think that will work. What else? Let's go Gunner, your group, you guys are going to do D. Ava, your group, you guys are going to go back and you're going to do B. And I would say Who's over there? Carson, your group, you guys are going to go and do C. I believe that makes sense. 5 groups, 5. Okay, that works. So you've been assigned your letters. See if you can make your meaningful equation. I'm going to stand off to the side. This will be a good time to pause. If I messed up any of the assigning of lines or letters, please fix that. Sorry, thinking off the top of my head. So use this, see if you can make your meaningful equation. Okay, good time to pause right now. Okay, so again, this is just practice. Hopefully you guys are good to go with your meaningful equations. We've been spending a lot of time on meaningful equations, and I don't think we really need to go over this because many of your equations are going to look like mine. The only thing that's realistically going to change about your meaningful equation, your position and your time are going to stay the same. That should stay the same for every single group. Your position over time unit for velocity, that should stay the same. Okay. The only thing that's going to change is potentially your slope. Now, some of you guys are going to have a tricky slope because if you are, for example, group 5, or not 5, group C, if you got assigned letter C, well, you know that over any time on the bottom, your position is always going to stay the same. It's always going to stay the same. It's not changing ever. And so your slope is going to be 0. Okay, it's going to be horizontal. Now, that's easy for you guys. For some of the other groups, it's going to be a little tougher because like B and D, these do have positive slopes, so this shouldn't be negative for you guys. And the question is, what is the numerical value you guys will attach to it? Well, it just depends on how it's going up over time. Like for example, you might have to say like over 10 seconds, B goes up 6 meters or goes 6 meters, and maybe D over 10 seconds travels 2 meters, maybe 3 meters, and then you have to find out what the slope is from there. Okay, so realistically, the only thing that's going to change for any specific group is your M value in the front, and then your it's going to be your X0 value, your starting position. And so, for example, for me, my starting position was 10 for A. For B and D, your starting position should be 0 meters, okay, 0 meters. And then for letter C, your starting position would be about 5 meters, okay? So meaningful equations are not going to go away. You have to remember those units, okay? So again, hopefully it's good practice, so on and so forth. Now, you will have a quiz about this one day, but we're not going to start that now. Speaking of quizzes, this will be a fabulous time to start going over said quizzes. So what I want you guys to do is put away everything. Put away whiteboards, clear them off, rags, markers, notebooks, don't need Chromebooks, clear everything off your desks, okay? I don't want any technology anywhere near these quizzes, okay? Once everyone has everything put away, I want you guys to go ahead and look at your quizzes, okay? So we're going to hand out the quizzes, and you guys are going to look them over. You may have questions. Sadly, I'm not here, so you can ask those questions individually to me during prime time, okay? Officially, saying this now, retakes, today's Tuesday. You have until next Tuesday to sign up for prime. Do a retake if you're interested, if you don't like your grade. But you can only qualify for retakes if you completed all your homework, okay? I will, at this point, have gone through the entirety of the grade book so far, and if there was any missing assignments in Infinite Campus or Canvas, I would have put them in as zeros, okay? Assignments are due. Their true solid due date is at the end of a unit, okay? So, with that being said, put everything away. We're going to hand out those quizzes so you can look at them. Once you're done looking at the quizzes, stack all the quizzes in the middle of your table, name side up, and then we'll collect those back, okay? This is a good time to pause. Okay, so quizzes. Hopefully you email me or let me know if you have any questions and you reach out about those retakes. The last thing that is expected of you guys, not only submit those labs, that's priority 1, but also on top of that, you do have a homework assignment for tonight. It is called Unit 2, Worksheet 1. It is due tomorrow morning, okay? So whatever time is left in class, I hope there is some time left in class, you guys are going to go ahead and work on that, okay? So with that being said, email me if you have any questions. The rest of the time is work time. As you know, no phones, okay? I'll see you guys tomorrow. Sorry for being gone. I hope you have a good day.